So let me remind you something that we talked about. If there's a function f defined as x plus 1 over x minus 3. Here's the function. In topic 2, when you see a function, the question was, are they going to ask me to give the domain, the range, the inverse, or what? Is it one-to-one? I mean, what question do they want to ask me? Now, you already answered those questions. Where we have reached now is the matter of sketching. Are you able to sketch this function? Now, let's start with what we know. What could be the domain of this function f? Or you would say x must be a real number such that x is not equal to 3. That would be the domain. Meaning, you can use any value of x, that is a real number, except 3. What is the range? Okay, remember what we are doing for the range? You would let this be y x plus 1 over x minus 3. Put a 1 down, cross multiply. What are we doing? Getting the inverse. Okay, so yx minus 3y is equal to x plus 1. And then we'll have yx minus x is 1 plus 3y. So that we factor out x and remain with 1 plus 3y over y minus 1. Okay, so you would say the inverse of this function is 1 plus 3x over x minus 1. But when getting the range, you would say y for real numbers such that y is not equal to what? At this stage, y is not equal to 1. Because if y is equal to 1, then there's a confusion. The denominator will be 0. And so x is undefined, meaning the inverse is undefined. Now, this was the domain and the range. When sketching, these two matter. Because the range is what you can get. And there's a question. What's the question?
Hello, sir.
Yes.
Yes. There was a question that they asked if the function was even or odd. Now, just by looking at the function, I said it was odd. Now, they said show your working. So now, let's say in this scenario, you ask us saying, what is the range? Then just by looking, I get the horizontal asymptote and say the range it's 1. Are they going to say show your working or what?
You haven't looked.
You haven't looked.
You have also said.
You have also said.
What your eyes have seen. Because you have said the horizontal asymptote.
Yes.
So you just find. So now, after we are now able to get the domain and the range, the story changes. Have you seen that it's complicated? We always have to solve for the inverse, even for simple things like this one. No. Terms now come. Say, okay. So instead of me coding when I'm taught to sketch, instead of me saying domain, I will just say vector asymptote. I'll just say vector asymptote. What do we mean? The line that cannot be touched on the graph. Okay, so I'll place my graph here. When I say vector asymptote, I mean the line. Since here we're saying x must not be equal to 3. On the graph, there's a line called x equal to 3. This line here. This line is called x is equal to 3. This is 3. Meaning x is 3 here. Now, since we are saying x must not be equal to 3, it becomes a vertical asymptote. So x is equal to 3 is the vertical asymptote. How do we get it? You equate the denominator to 0. Okay? So, to find the vertical asymptote, equate the denominator to 0. And do what? And so forth. That is enough. When you do that, you have found the vertical asymptote. How do you use it? You got your graph and draw those lines. You can find 4 of them, 2, 3, 1. The line. After that, you look for what we call the horizontal asymptote. Horizontal asymptote. Horizontal asymptote. Where is it coming from? From the range. The concept of the range. Now this one, we will have cases. Case number 1. Okay. If the highest powers of the denominator and numerator are equal. Divide the coefficients of the numerator over number. That is case number 1. Case number 2. If the denominator has the power higher than the numerator, okay, what you do? Then the horizontal asymptote is always equal to 0. The third case does not exist in first year. We'll talk about it when we go to second year, where the numerator has a higher power than the denominator. That case, not in this. So it means that we've established a way of getting these two. So one, we've gotten the vertical. Now let's go to the horizontal. What are we saying? The powers are equal. So we'll get the coefficients. So horizontal asymptote, we'll have the coefficient of this x is 1, over the coefficient of this x is also 1. Now 1 over 1 is 1. So we go to 1 and draw another. Now this time around, it's the 1 for y. So this is 1. Now we can sketch. So we have put the boundaries. On these boundaries, the graph cannot touch. That's the implication. It should not touch. Okay? But there are special cases. There are special cases. When you see x in the numerator, you must always get tempted to get the whole numerator and equate it to the horizontal asymptote. Now here, the horizontal is 1. Is it not possible to get a 1 up there? Or let's say, so that we do it for every function. So you get the whole function, x plus 1 over x minus 3, and equate it to the horizontal asymptote. And check if that is possible. Now, in this case, obviously it's not possible because we're going to have x plus 1 equal to x minus 3. So this will tell us that 1 is equal to negative 3. It's not possible. So you may not want to go through that thing. You may just have your asymptotes and then sketch. So how do I sketch them? Now I go to, so after I put the lines, then I go to the horizontal asymptote. I mean the vertical. The vertical is 3. So I pick two numbers, one bigger than 3 and the other one less than 3. Now let's start with one that is bigger than 3. So let's pick 4 and put it in the function. So we have 4 plus 1 over 4 minus 3. This will give us 5 over 1, which is 5. Now that 5 I'm getting, that 5, I need to check, is it higher than the horizontal asymptote or not? Look, for us to pick the number to use in the function, we picked a 4 that was bigger than the vertical asymptote. The answer we get, we compare it to the what? Horizontal asymptote. So we have found a 5 that is bigger than the horizontal, meaning that the graph is going to be upward without touching the line. Then we go to the left and pick a number less than the vertical asymptote. Let's pick 0. What is f of 0? F of 0 is 1 over negative 3. Is 1 over negative 3 less than or greater than 1? This is less than 1, which is what? The horizontal asymptote. So the graph is going to be down. And the beauty is that we have used the 0. So we know the y-intercept. It's at negative 1 over 3. Negative 1 over 3. Okay. So the graph is going to go up. You can even tell what this is by going to the numerator and equating it to 0 so that we get a negative 1. So we have sketched it. What do we need for you to sketch a rational function? 1, the vertical asymptote. 2, the horizontal. Any question?
Yes, sir. Do you mind repeating why you picked 0? Is it okay if, let's say, we pick 2, because 2 is less than 3?
It's very much okay.
The graph will just come out the same or it's going to be different?
Yes, sir. Except that you have more work to do. Because in a test, they'll tell you, state the intercepts. So if you use 2, it won't tell you the intercept. But if you use 0, the then number you get will be the y-intercept.
So I was missing. Thank you, sir.
Yeah, me, I didn't understand this part, this same part I'm explaining for equating to 0. For using the 0 part is for this other graph, like not the top part, but the down part.
So the down part we have said, since for us to sketch the upper part, we pick the number that was bigger than 3. We pick the 4, which lies somewhere here. Substituted, got that number, and we discovered it was bigger than 1. So we put the graph up there. That we understand. So when we come to the other side, you need to pick a number that is less than 3. Now we have so many numbers less than 3 here. Now remember that when you're sketching quadratic functions or any other function that you have sketched, how are we finding the y-intercept? We're using x is equal to 0. Now, lucky enough, this is the 3. And they're looking for a number less than 3. It's so obvious that 0 is part of those numbers. It's also less than 3. Now, because 0 would tell us something else, 0 would tell us where the graph is going to be, 1. It will also tell us where the graph touches the y-intercept. So we place 0 here in the original function, just like we placed before. And the answer comes out to be 0 plus 0 plus 1, that would be 1, 0 minus 3 minus 3. So we get a negative 1 over 3, which is less than 1. What is 1? 1 is the horizontal symptom. So because the answer we get is less than 1, the graph is going to be below here and to the left of the there. Now, in the below, we're getting a negative 1 over 3, meaning that that is the intercept. That is the y-intercept. That was the good thing of using a 0. And then, since we also have another intercept, we have the x-intercept. So we get the whole function and equate it to 0. Now, getting a fraction is the same thing as equating the numerator to 0 because the denominator will also multiply into 0 and into that.
Okay, so I've gotten the point.
Okay, let's do another question. Yes?
It's a quick one. On that negative 1 on the negative values for the x, how have we found that negative 1 while the graph is crossing the x values?
So that number is called the x-intercept, which we get after equating the whole function to 0. Because we understand f is y. So when y is 0, we are on the x-axis. Now what is f? F is x plus 1 over x minus 3. When you get it to 0, we discover that when we cross multiply, we have x plus 1 equal to 0, meaning x is equal to minus 4.
All right, thank you.
Sir,
Mhm.
so what's the x-intercept?
It's negative 1. X equal to negative 1.
How did you find it?
You equate the whole function f to 0 and solve for x. Are you connecting the function f to 0, which is here, to 0? As if you place over 1 and cross multiply, you have x plus 1 times 1, x plus 1. X minus 3 times 0 is 0. Take 1 the other side. So x is equal to -1. And we call it x intercept.
I get.
Sir,
Mhm.
I saw a video of you saying you equate the whole function to 1 to the horizontal asymptote, sorry.
If you are looking for,
Huh?
if you are looking for,
I don't know. There's a question that you are solving. You just equated the whole function to the horizontal asymptote. And if you want to know if there's an abnormal behavior.
yeah, I almost said it here, but it failed. Have you seen? It was giving us 1 is equal to -3, which is not the truth. So I'll mention it at some point.
Okay.
I'll explain it. So even if we picked a 2 here, suppose we picked a 2, the intercepts, they are not going to be distinct. We're still going, when we need them, we're still going to get -1/3 and -1. Because a 2 would have just told us that, oh, the number you're getting is below 1. So put your graph down here. Where it cuts the y, you need to find when x is 0. Where it cuts the x, you need to find when y is 0. Okay? Let's do another one. Example 2. F of x is equal to x x minus 1 over x squared minus 4. X minus 1 over x squared minus 4. So we go direct. What's the vertical asymptote? We equate x squared minus 4 to 0. That is x squared is equal to 4. Get the square root, get the square root. So we have x is equal to plus or minus 2. So on our graph, we have -2 and +2 as the x-intercept. Okay, the y-intercept, the horizontal asymptote, I mean, we are saying since the power of the denominator is higher than that of the numerator, so go straight and say y is equal to 0. So when we come here, y is equal to 0 is the horizontal asymptote. Okay, so now you can now do that thing of picking a number bigger than 2, in between, and 1 less than -2. Now that we have 2 asymptotes that are vertical. So let's pick Then we start on the left. Let's pick a -3. Let's pick -3. What would be f of -3? It will be -3 minus 1 over -3 squared minus 4. That is -4 over 9 minus 4 is +5. So we are getting a negative number. Now, all negative numbers are less than 0. What is 0? 0 is the horizontal asymptote. So the graph here is expected to be down. A number in between -2 and 2. Let's go straight to 0 when x is 0. So when x is 0, we'll have -1 over -4, which is 1 over 4. Up here, 1 over 4. Now let's check. Is there any abnormality in this question? Since we have said the horizontal asymptote is y is equal to 0, let's get the whole function x minus 1 over x squared minus 4 and equate it to 0 and see if it makes sense. So we'll have, when you cross multiply, we'll have x minus 1 is equal to 0, giving us x is equal to 1. It's very possible that when x is 1, we'll actually get 0, which is the horizontal asymptote, which is the horizontal asymptote.
Sir.
So we have an abnormality here.
Sir.
Yes.
Oh, okay, it's okay. That's correct.
Okay. So it means that the graph, which was supposed to be up, will now cut the asymptote. So it will come this way. It will cut that one. And then we pick a number bigger than 2. Let's pick 3.
So before you go picking the number bigger than 2, can you just repeat this part for this graph that's cutting the horizontal asymptote?
So look, our horizontal asymptote is y is equal to 0, right? So we need to check, since we are seeing x in the numerator, there is a possibility of the numerator being 0. Now, when the numerator is 0, no matter what the denominator becomes, unless it is 0, then you're going to have a 0. So in this case, we have x up there. So there's a possibility that for some values x, this whole thing can be 0. But here we are saying horizontal is 0, meaning we don't expect to have a 0 unless otherwise. Now we have the unless otherwise case, because we have seen that when this is equated to 0, it's coming out that there's actually a number x that can give us a 0 for sure. And that number is 1. So if we find it, we won't put, because we are supposed to put a curve up here. But since we found a number bigger than the horizontal asymptote. But because of that special case, the graph is going to cut. So if it cuts, then it will go down.
Okay, sir.
So now, let's pick a number bigger than 2. Say 3. What would be f of 3? It will be 3 minus 1 over 3 squared minus 4. That is 2 over 9 minus 4, that's 5. 2 over 5 is positive, bigger than 0. So the graph is going to be up here. Because There's a question?
Yes, sir.
Mhm.
Network is really bad here. How would you know that the graph is not going to cut the x intercept? Now, let's say if the answer that we got after equating it to the horizontal asymptote was 3, that's when you know that it won't cut the x.
No. How you know is when the answer you get does not make sense. Are you seeing that? We got 1 is equal to
Yes.
-3, which is not possible.
Come again. Come.
So look, in this question, we equated the whole function to the horizontal, is it?
Yes, sir.
After we solved, it gave us that 1 is equal to -3.
Okay.
And that is not possible, right?
Yes, sir.
So because it's not possible, then we said, oh, then it cannot cut the horizontal asymptote. Now, this case, we tried that, and it gave us x is equal to 1, which is possible.
Yes, sir.
Then we know that, oh, then this one cuts. And cases where it cuts are the cases when the x-axis becomes the horizontal asymptote. When there is a variable in the numerator and the denominator has a higher power, then we expect that to be. So these are wow, good questions because then we only have 2 cases. So the other case does not exist in this case. So we have the first case as example 1, the second case as example 2. And that is enough for a Friday like this one. So that you will enjoy the weekend and we'll have a class on Monday where we'll now sketch the modulus functions. That will be the target. Those functions of this kind this situation, you cannot afford to miss this. These classes are not for missing because they're very nice.
Sir,
Yes.
sir,
Hello.
is it okay if you can?
You're not taking I didn't hear your question. Come again, please.
The question, how can you just go back because I didn't understand the first example why you want
Is someone speaking? So the session will be cutting itself just seconds from now. So I was hoping to get that question, but I didn't.
Yes, I have a question. Can you just go back and explain why the first example failed to cut the horizontal asymptote?
Oh, because it did not make sense. The solution we got was saying 1 is equal to -3, which is not the case. This can never be true. In the other case, we got x is equal to 1, which makes sense.
Sorry again.